Principle of dimensioning. Every drawing consists of the views necessary to describe the shape of the object and must supply its exact length, width, height, size, position of holes, and any other details required for the manufacturing of the object. Supplying this information on a drawing is called dimensioning. Type of dimensions. So we have two types of dimensions. One is size or function dimension, other is location or datum dimension. So as representing this object, 40 here representing the size dimension because it represents the size of the object. 22 here represents the location dimension because it represents the location of center of this circle from the edge. So this is called location or datum dimension. Elements of drawing. So in this case, the elements of dimension include the extension or projection line, dimension line, leader line, arrowhead, and the dimension itself. Various elements of dimensions are represented in the diagram. You can see over here is leader line here, extension or projection line, dimension line, this one. This is the value of dimension and arrowhead. Now is the execution of dimension. So very first is projection line should be drawn from the visible feature of the object and extend slightly beyond the dimension line. As you can see over here is this extension line is starting from the exact object and extended beyond the dimension line. In this case, that is not extended beyond, this is up to the dimension line. So this is incorrect, this one is correct. In second case, mutual crossing of dimension and projection line should be avoided. You can see in this diagram, here is dimension line, longer dimension line, this shorter dimension line. So in this case, shorter one is inside and longer one is outside. So in second one, you can see longer one is inside, shorter one is outside. So extension line is crossing the dimension line here. You can see here, extension line of 10 is crossing the dimension line of 30. So this is incorrect, but this is correct. In the third case, you can see projection or extension line must be drawn perpendicular to the part to which it is to be dimensioned. As you can see here, so this is perpendicular to the part of the object, and same way here is perpendicular to the part of the object. This one is in fourth number. So you can see the proportion of this arrowhead. So if the width is x, so its length must be 3x, 3 times the width of the object. Now is the method of dimensioning. So we have 3 types of method of dimensioning, that is chain dimensioning, parallel dimensioning, and combined dimensioning. You can see in this first one is chain dimensioning. So in this case, you can see dimension start from this reference line and extend up to edge of this length. For second dimension, this start from the end of last dimension line and extend up to the end of the length of the line. Similarly, third one is start from the end of previous dimension line to the end of the length of object. So this will look like a chain. So that's why it is called chain dimensioning. In the second case, parallel dimensioning, you can see there is a single reference line from which dimension started. So this is first length. So starting from here up to the end of this length. For second length up to this one is starting with the same reference line and up to this end of the length of this object. Similarly for third one. So these are parallel to each other. So that's why it is called parallel dimensioning. In the combined dimensioning, you can see this side we have a chain dimensioning and this side is parallel dimensioning. So that's why it is called combined dimensioning. Placing of dimensioning. So we have 2 methods to place a dimension, that is aligned system and unidirectional system. In aligned system, you can see in aligned system all the dimensions are placed above the dimension line, like there you can see above a dimension line, and they may be read either from the bottom or from the right hand side of the drawing. So you can see this is read from the bottom of the object, this is right side of the object. This is called aligned system. In the unidirectional system, all the dimensions are placed in one directions. All the dimensions placed in one directions such that they may be read from the bottom of the drawing. So you can see here, so all these we can read from the bottom of the drawing. So that's what is called unidirectional from one side. Aligned system, unidirectional system. Now is principles of dimensioning. So as mentioned here, very first is dimension indicated in one view need not be repeat in other view. You can see here, as this is front view, this is side view, this one is top view. So its height is mentioned over here is 25. So in this case, this should not be repeat in the side view because it is mentioned in the front view already. Second is dimension should place outside the view. As here we can see here, this is some view is mentioned to us. So dimension is written on the view. So this is incorrect. So we have to place this dimension outside the view. This one is correct one, this is incorrect. Larger dimension should be placed after the smaller dimension. As already discussed, so we have to place larger dimension after shorter dimension. So this one is correct because in this case, this extension line is not intersecting with any dimension line. But in this case, you can see the extension line of 10th unit is intersecting with the dimension line. So this is incorrect, this one is correct. Dimension lines should be drawn at least 5 to 8 mm away from the outline and from each other. So we have to make this distance, or we can separation, uniform. Dimensioning of a cylindrical part should, as far as possible, be placed in view in which they are seen rectangle. So as you can see over here, this is some view, front view and side views there. So we have to dimension cylindrical part in this view because here we can see they are like a rectangle. So we have to dimension here, not in this front top view or side view. So next is dimension indicating a diameter should always be preceded by symbol phi. So as in this diagram you can see, so we represent here diameter. So that's why we put a phi symbol in front of the magnitude of the dimension. Arc of the circle should be dimensioned by their respective radii. Dimension line for the radius should pass through the center of the arc. So as you can see here is arc. So we have mentioned this one is as radius. So here is the radius of arc is 10. So it is passing through the center of the arc. Angular dimension may be given by any one of the method as shown. So depending upon the angle, if it is very small, so we can indicate like this, and later on we can, if the value of the angle is more, so we can represent either this or this side. Now is holes should be dimensioned in the view in which they appear as circle. If we are dimensioning a circle, so we should dimension it the view in which it is looking like circle, as this is a front and side view of the any object in which there is a hole. So we represent the diameter in the view in which they appear as a circle. So we have to make clear, in the case of circle we will dimension in the as the case of hole we have mentioned in the case of in which they looks like a circle, but in the case of cylindrical parts we will dimension in which they represent as a rectangle or appear as a rectangle.